Okay, so we're starting here looking at complex numbers. We'll look at what complex numbers are made of, how they're made up, and a couple of kind of basic operations involved with them. So to start with, as a definition, we would define, for purple, the square root of -1 equal to I. Okay, and what we've done is, it came about in mathematics that there were some problems that we couldn't solve the answers to. So you're thinking back to your discriminant, you get your b squared minus 4ac. If that was less than 0, there were no real solutions, and that was where we became very insistent at kind of National 5 level that you use the word real roots, because what we've done is we've just created some imaginary maths to find some solutions, okay, which is possibly one of the most mathematical things we've ever done, just to ensure that we can continue to do maths. We've created and invented some numbers that don't really exist in real life. So we're going to define the square root of -1 as I. So just to kind of keep that going, if we think about what happens if we've got I squared, then that would be the square root of -1 times the square root of -1. So that just gives me -1. If we want to do I cubed, then that is the same as I squared times I, and so I end up getting minus I. And if I want to do I to the 4th power, that is the same as I squared times I squared, so I end up just getting 1. Okay, these are helpful little things just to kind of keep you going when you're doing it. Okay, you'll be asked to do a whole load of things that involve I and multiples of I, and if you can tidy it up as you're working your way through it, it'll stop it getting kind of too out of hand and too unmanageable. Okay, in general, we can define complex numbers by we always go for Z equals A plus IB. Okay, and what we're looking at here is we've got a complex number and it's made up of 2 parts. Okay, and we'll explore that a little bit more detail in the next bit, but we've got this bit here, which is my real part, and I've got that bit there, which is my imaginary part. And I'm going to check the word parts in there, just for the sake of it. So what we can do is we might want to define one complex number. It's 2 plus 3i, and another one as 3 minus 4i. Okay, so again, I've got a complex number made up here of a real part, here of an imaginary bit, another one, real, imaginary. So if we want to do one complex number plus another complex number, we just write them just like that. So we get 2 plus 3i plus 3 minus 4i. And this is where it becomes a little bit like algebra that you've seen before. We're looking to add together, essentially, our like terms. So we can add together all the real bits. I've got 2 plus 3 gives me 5. And then I can deal with all the imaginary bits. So I've got 3i minus 4i. It's just minus I there. If we want to multiply them together. Okay, again, we can do that, treating it almost as though it was algebra. Multiply out your brackets, you're going to end up getting 6 minus 8i plus 9i minus 12i squared. Okay, and this is going to be one of these instances, again, where we are remembering that I squared is equal to -1. So we can tidy it up, and we're going to find that we get 18 plus I. And so when we're dealing with it, our answer should always take the same form. When you're dealing with this bit here, you should only ever have a real part, is 18, and my imaginary part, which is just I here. Okay, there should be no other bits, right? There is no other thing that should be coming there, right? Real part, imaginary part. Okay. When we ask you to try and divide and find the square roots of these are a little bit more complicated, so we'll look at them in a different video. But if we want to add, subtract, multiply, we would do it just the same way that we would always have done. Third pretty common example that we might ask you to do is we might ask you to solve something like x squared plus 2x plus 5 equals 0. So you could try and factorise it if you wanted to, but you'll find that it doesn't work. So we're going to stick it into the formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, that formula that you are expected to know now. Shove your numbers in, you're going to get minus 2 plus or minus the square root of 2 squared minus 4 times 1 times 5 all over 2. Tidying that up, you get minus 2 plus or minus the square root of minus 16 over 2. Okay, and this is where we're thinking about what we're doing when we're trying to get these complex numbers. So we said square root minus 1 was equal to I. Whenever we've got a square root with a negative number in it, what we are going to do is we are going to split it up, okay, just like we did simplifying our surds, so that one of them is minus 1. And all it's going to be then that's left is just the number. So minus the square root of minus 16 is the same as the square root of 16 times the square root of minus 1. Okay, and that is going to give me root 16i, square root of 16, plus or minus 4i. Okay, what we could have done is if we had said the square root of minus 9, it would be the square root of 9 times the square root of minus 1. So all we're doing is we're essentially taking that negative part out of it, okay, so that we can deal with the horrible bit under the guise of this I instead. So that then brings me back to my answer. So I've got equals minus 2 plus or minus 4i over 2. Remembering how your fractions work. And so that is going to mean here then that x is equal to minus 1 plus 2i minus 1 minus 2i.